Okay, what we're going to look at here is what we know as dipping ranges, and involving geographical range table, extreme range table, etc., which we'll have a look at shortly. So if you're on a vessel and you observe a single light, you can actually get an approximate position for your vessel. As long as you can obtain the bearing of the light as it's seen to dip below or rise above the horizon. So if we're steaming along in a vessel towards or away from a light, as it dips below or rises above the horizon, if you get a bearing at that time, you can get an approximate position because you are able to calculate an approximate distance off the light. And this is where these tables come into play. And we have what's called the geographical range table, which I've got in front of me here, which we can use, and we can also use two other tables that are in Norris. The geographical range table is in the Admiralty list of lights. The tables in Norris are the extreme range table and the distance of the sea horizon table. Now, in addition to other sort of minor criteria, the dipping range of a light depends on refraction of the atmosphere, and that's the light passing through different atmospheric mediums. And the three different tables we're going to look at do allow for slightly different levels of refraction. So the compilers are all slightly different in the values, but only very slightly. And of course, abnormal refraction can cause considerable variation in the dipping ranges. Let's just have a look at a quick sketch before we go any further. And on this drawing here, I've drawn, that would be, say, your vessel there. And as you know, the Earth isn't flat, it's round, okay. So, we've got a height of eye here, for example, of 19 metres. It means that over we can see a certain distance before dipping below the horizon. And if we're heading towards, say, a lighthouse that has a certain elevation, then that lighthouse again will be seen at a certain distance. And if we can calculate these two distances, then we can calculate an approximate distance in total that we would be off the lighthouse when it came into view or disappeared from view. And this is where the tables come in to help us. So let's have a look at the tables. Let's have a look first of all at what we call the geographical range table. Now, the two values that you need in all three tables, one is your own height of eye, which is shown here, your vessel. So whatever your height of eye is on the vessel, that's a value you need. And you also need the elevation of the lighthouse or any other light that you're heading towards or going away from. And on the chart, I've just written one example here: straight point light, flash white every 10 seconds, 34M, small m, 9, large M. The small m represents meters. So what that means is straight point light elevates 34 meters above mean high water springs, and it's seen at a distance of 9 miles, but its elevation is 34 miles. So if we look at our example here of the lighthouse, if we go along the top of the geographical range table, you've got to be careful because the values are given in feet and meters. It says here height of eye of the observer. So your height of eye is 19 meters. So you go along the top until you reach 19 meters. In this instance, it's between 18 and 20. Then you go along to find the elevation. So on the left hand side is the elevation of the lighthouse. So again, be careful with meters and feet, and we need to go down here until we can find an elevation of 42 meters. So between 40 and 45 is 42, and our elevation is between 18 and 20. So in effect, as it says here, the range in sea miles, in other words, the range in sea miles at which you'll see the lighthouse is going to be, by interpolation, around 22 miles. So what that's done, that's combined your height of eye and the elevation of the lighthouse to tell you that at approximately 22 miles you will see the lighthouse from your vessel under normal visibility. Let's have a look at the other two tables. So we've just looked at the geographical range table. The tables in Norwich, one is called the extreme range table, and that again has along the top height of eye, so we're at 19 metres, and we have an elevation of 42 metres. So if we go down here to 45 metres, elevation 18 to 20, we can see again the value is, by interpolation, will be approximately 22 miles. You'll get 0.1 or 0.2 miles difference between these three values, but they'll all be more or less the same. So extreme range table using height of eye along the top again and the elevation along the side, being careful to use metres rather than feet if you're dealing in metres. Then we have what's known as the distance of the sea horizon table. What we do with this table, we go in with both values individually. So we look up 19 metres, and here's the metres here, and we can see at 19 metres the distance is 9.1 miles. So what that's saying is from our vessel in normal visibility we will be able to see for 9.1 miles with our elevation of 19 metres. The lighthouse is 42 metres away, so 42 metres here, not feet, metres. It tells us that that will be seen at a distance of 13.6 miles. So if we add those two together, 13.6 and 9.1, that gives us 22.7 miles. So using the distance of the sea horizon table gives us 22.7 miles. So you can see you can use all three tables, distance of the sea horizon, extreme range, or your geographical range table, to obtain the dipping range, the distance. So once you've got that range and you've got the bearing, you can plot an approximate position for the vessel.